This is the video for Mod 8, Lesson 6, Special Quadrilaterals on the Coordinate Plane. So the goal of this is going to be using the distance formula or Pythagorean theorem to classify special quadrilaterals, and also using slope to classify special quadrilaterals. So a quadrilateral is a figure that has or a polygon that has four sides and four angles. So when we talk about a special quadrilateral, we're still talking about four-sided figures, but they have special properties with angles or sides. So one special quadrilateral is a parallelogram, and this is kind of like an umbrella category that has like some stuff that's more specific with it. So a parallelogram is a four-sided figure or quadrilateral where the opposite sides are going to be parallel to each other, hence the name parallelogram. And the opposite sides are also going to be congruent to each other. So we're going to find there's a whole bunch of other properties with parallelograms, but the main ones we're going to see are that the opposite sides are going to be the same length, and they're going to have the same slope. So when we do talk about coordinate geometry, we're going to see our slope formula and our distance formula or our length be used in these problems. Underneath the topic of parallelogram is we can get a little more specific. So a parallelogram that has four equal angles, remember quadrilaterals add up to 360. If there's four equal angles or four right angles, we say that's a rectangle, right? So notice that it's going to have four right angles. On the coordinate plane, we're going to find that the opposite sides are going to have the same slope, like a parallelogram. The opposite sides are going to have the same length, like a parallelogram. But the only thing that's a little bit added to that is the sides next to each other, the adjacent sides, are going to have perpendicular slopes, so opposite reciprocal slopes. Another type of parallelogram we can have is a rhombus. So a rhombus is where you have four equal sides. It doesn't have to have equal angles, but just four equal sides. And so on the coordinate plane, in addition to all the opposite sides having the same slope, which is true for a parallelogram, what makes it a little more specific to a rhombus is all the sides are going to be the same length. And then finally, a square is also a parallelogram. So it's going to have all the properties of a rhombus and a rectangle. So it's really kind of those two properties put together, right? A rhombus and rectangle put together. So you're going to find that the opposite sides have the same slope, all the sides have the same length, and then the adjacent sides, or the sides next to each other, have perpendicular slopes. Two quadrilaterals, I should say, that we're going to see that are not parallelograms are going to be a trapezoid and a kite. So they're not going to have your properties of a parallelogram. For a trapezoid, you're going to find that one pair of sides are going to be parallel. Typically, we call those the bases. So you're going to have a base, so base 1, base 2, so you're going to have two bases and they're parallel, and that's really the only property you're going to see with that. The other two legs, we call them, are going to kind of do their own thing. And then a kite is going to have two pairs of sides equal, but they're the sides that are next to each other, not across from each other. So on the coordinate plane, we're going to use our distance formula or Pythagorean theorem to find the lengths, and we'll find two pairs of lengths that are the same, but they're not across from each other, they're next to each other. In this first example, the question says plot each quadrilateral, and then we're going to use slope and distance to classify what type of quadrilateral this is. So the first thing we're going to do is plot this quadrilateral to kind of see what sides or what points are making up the different sides. So we have point M is -2, 1. So I have point M right here. We have A is 6, -1. We have T as 3, 4. And then h is 1, negative 4. Okay, and so and I'm just going to do my best to plot these together. So we can see we have a four-sided figure. It's going to be plotted because we can see the segments that make up, or the points that make up those different segments, right? So we actually have 4 different sides here. We have one side that is MT. All right, we have another side that is TA. We have another side that is AH. And then this last side that's MH. Okay, so what we're going to do is we're going to use these different sides or points to do the slope and the distance, right? So you can see MT is negative 2, 1, and 3, 4. TA is 3, 4, and 6, negative 1. AH is 6, negative 1, and 1, negative 4. And then finally, MH is negative 2, 1, and 1, negative 4. So what we're going to do is we're going to find the slope and the distance or the length for these segments, and then see if what we can classify as, right? And we might not have to find every single length and slope, but we're going to see, like we saw in the previous lesson in 8.3, we actually don't have to keep reinventing the wheel. Once we do our slope, we can easily switch that to finding the length by using the distance formula, which is essentially Pythagorean theorem. So the first thing is we look at MT. We're going to calculate our slope. Remembering the subtractions part of the formula, and we can put our points in any order as long as we're just consistent how we do it. So if I choose the top to be 4 minus 1, I have to make the bottom 3 minus negative 2. So then when we do our first slope, we're going to end up with 3 over 5. And then if we go ahead and do Pythagorean theorem or the distance formula, because really that's, if I use this part, I can use the distance formula here. And then we're actually going to get the length, maybe I put the distance, but my length to be 3 squared plus 5 squared, right? Because that's just the same as that difference. And then we're going to get that to be root 34. In our picture, we may want to label that out just so we have it. So we can see that MT would be root 34 is the length, and the slope is 3/5. We're now going to do the same thing with the remaining 3 sides. If you look at the rest of the problem, we were able to calculate the slope and length for the remaining 3 pieces, right? So you can see over on the diagram a couple of things that we can kind of classify, right? So we see we have 4 sides that are the same, right? So if we look at our different ways to classify, we know that there's really only 2 figures that have 4 sides the same. It could either be a rhombus or it can be a square, right? So we're going to see which of these is actually going to be. So the big difference between a rhombus and a square is a rhombus doesn't necessarily have to have right angles. So if I look at my slopes, these are actually opposite reciprocal slopes. So this is going to actually make a right angle. Same thing with the other four pieces we have here. So since we have 4 right angles, it's a rhombus, it's also a rectangle, which means the more specific name we would say is this is actually going to be a square, right? So so I have 4 sides that are the same, they also make right angles, so we would classify this as a square. The next example is done the same way. So we're going to go ahead and first plot our different points. So we have our points 5, 5. And that's point O. We have our point 0, 0, which we're going to call L. We have our point 8, 4. And then our point 7, 1. So if we go ahead and connect these points, all right, these are the segments that we're now going to work with. So I have these segments listed here. So I might list the segment OV, and I'm going to now find the slope and the distance for that. I also have the segment VE, the segment EL, and then the segment OL. And so what we're going to do is we're going to take these points and we're going to go ahead and calculate, for all of them, we're going to calculate the slope and we're going to calculate the length or the distance and compare what type of figure to classify this figure. Once we calculate the slope and distance for all 4 sides, we can kind of see what our relationship is going to be. So from this problem, we see that we have 2 pairs of sides that are going to be the same, but notice that they're not the opposite sides, right? So this is actually not a parallelogram. And if we look at our options that we have, it actually ends up being a kite, right? Because we have 2 pairs of congruent sides, but they're the sides that are adjacent or next to each other. So we would classify this as a kite. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.